Look at area of a trapezoid. So here's our area formula. The area is equal to side A plus side B, okay, in brackets. Then that number times h, and then all of the above divided by 2. Okay? That's the order we'd solve it. So let's take a look at our trapezoid down here. We have our trapezoid, and we have to figure out how we're going to label A, B, and H. Okay? The area of the trapezoid is essentially the space that the trapezoid takes up. So everything within it, right? This is the area. That's what we're trying to solve for, how much space that is. Our A and B sides need to be parallel. So if we quickly take a look, our parallel sides are the top and bottom of this specific one. Okay, if these aren't, if we're not referring to the parallel ones, we can't call it A and B. Okay, so this side and this side can't be called A and B because they're not parallel. One's going this way, one's going this way. If we extended them, they'd essentially cross. And we know parallel lines will never cross, right? So we're going to call them A and B. And I can call the top A and the bottom B, or vice versa. It doesn't make a difference. So let's call this A, and we'll call this side B. H stands for the height, and the height is the straight line distance between the two parallel sides. So if these are the two parallel sides, the straight line distance is right here. It's 2 centimeters, right? So that will be our H value. Okay, we'll call that H. And we know that the other distance couldn't be height, right? First of all, we know because these two aren't parallel, but also because these distances continuously change, okay? And we know our height essentially needs to be constant here, minus these slanting parts for what I'm talking about. Okay, so we've labeled our trapezoid here. Let's plug it in, and then let's talk about why this formula works. So we'll plug our values in. We have our area is equal to side A is 2 centimeters, okay, plus side B, which is 4 centimeters, okay, and then that number is going to be multiplied by our H value, which is again 2 centimeters, and all of that will be divided by 2. We happen to be using a lot of 2's in this one, in this example. Okay? So according to BEDMAS, we deal with what's in the brackets first. 2 plus 4 is 6, so we have 6 times 2 divided by 2. Okay, we'll walk this through. Some of you might already know what the answer is going to be. 6 times 2 will give us 12 divided by 2. And then 12 divided by 2 is, again, 6. Now, our unit, these are all straight line distances. They're one-dimensional, but area is essentially a two-dimensional with a height and width. So we're talking about centimeters, second dimension, so power of 2, or centimeters squared. So 6 centimeters squared is our area. So why does this formula work? Well, let's take the info here. Now, if you take a look, 2 is exactly in our graphing paper. It's 2 of these bricks or squares sideways, okay? And the 4 one is 1, 2, 3, 4. So I've drawn it to scale, okay? So what I'm going to do is I'm going to take this side A and bring it down here. So I'm going to add it, okay? So think of like we've put side A and side B together. That's what the formula is asking us to do, right? This formula is saying A plus B. So here's our A and our B together. Okay, and if you're used to finding quadrilateral or four-sided shapes area, we know we do the width, length times width, okay, or the height times the width. And our height is still our 2 centimeters here. So if we just kind of extend this, this looks really close to our trapezoid. In fact, the only part we're missing is this part over here. And I'm going to kind of draw it, and I'm going to swing it over just to show you what it makes. So I'm going to group them together. I think I can do that. C group. Oops. Try it again. So here's that unknown space. I'm going to move it. Oops. This unknown space. There we go. And I'm going to spin it. No, I'm going to keep it like this, actually. And if you look, okay, and I know that one side kind of went missing. Let's draw it back in. If you look, this is essentially the same trapezoid, right? We know that this side and this side are the same length, and this side and this are the same length. If we count, we're 1, 2, 3, 4, and 1, 2. So there's our A and there's our B again. Okay, so what we're essentially doing, I'm going to move this again, spin it back to where it was. Okay, oops, sorry, it wasn't spun before. What we're essentially doing in the trapezoid formula, just want to show you that it makes that, is here's our height. And what we're really doing is we're taking A plus B times H, so that's this side length here, times this height, Okay, and we know 4 plus 2 is 6. Okay, so I'll write that out. A and B, we knew that was 6 times 2, which is the height. Okay, and the reason we're dividing it by 2 is because we've actually found the area of 2 trapezoids, right? And the reason it's 2, like we said before, this is our trapezoid again. So the reason we divide by 2 in our formula, okay, is because we have not only one area, but we've actually found it for 2 when we do all the stuff on top. But we know that we don't need this part, so we cut it out by dividing by 2. And that's how we essentially get the area of a trapezoid formula. So if you just want to know how to find it, you put it into that formula, and that's why the formula